So if you go back to the slides here, so the partners in this, it's really a pan-industry project. First and foremost, WPMA, the New Zealand Wood Processors and Manufacturers Association, coupled with other organizations and companies putting up funding to essentially develop a whole suite of design guides around timber and designing with timber. The designing for prefabrication is one of them. A few words on the overall project, because it may be quite interesting for the audience. So the NZ Wood Design Guide project aims to develop a total of 15 guides with the first 600 Ks worth of funding. There's a design guide designed for fire safety, which has been completed and is out for use. Designing for prefabrication is the second one in this series, and that's now out for public comment. So that's the version you've got in front of you. And there's 7 further guides that are at various stages of development at the moment. So there's going to be coming out one on quantity surveying, on standard connections, cassette panels, and the mentioned fire safety, and a few others. But the overall vision is actually even bigger than that. So there's, it's meant to be a 3 to 4 year project with a total of possibly up to 54 guides to be developed, planned in total. And at the moment, WPMA and these partners are looking for further funding being sought from through a primary growth fund for the NZ Wood Design Centre. So watch this space. In particular now, talking about the designing for prefabrication guide, what I'm going to give you today is an introduction, a cross-section. I pick out some chapters. I won't be able to cover the whole guide because it's quite a lengthy document, but hopefully it'll create some interest and it'll make you download the document and use it, most importantly. So it's really been developed with aimed at architects and engineers, designers and specifiers, architects and engineers that have maybe an interest already. Prefabrication is on their radar, but they are relatively new to prefabrication and or timber systems. So it's really aimed at that target audience. The guide has been just like any good prefab project, it's been a true work of collaboration with a working group behind it. The names here on the screen: Ian Jack on behalf of XLAM, Julian Addington, ENGCO, Richard Jack, WR Jacks, and Andy Van Hout in the immediate working group. And then there's also been a number of subject matter experts that I've pulled in chapter by chapter because it's quite a panoramic guide. In particular, I'd like to acknowledge John Gardner from Building Confidence Limited, Thomas Kastner, Naylor Love, Wouter van Beerschoten, and Boris de Buc from Concision, Matt Kusil, Björn Stankiewicz from ENGCO, Leah Singer, Pam Bell, Prefab NZ, and Peter Marmont from DesignBase. So a true work of collaboration, and all these individuals have helped to inform the guide. Coming to the guide itself, this is the table of contents of the guide, not the presentation today. What you can see is we start talking about timber systems and then talk about design for manufacture and assembly, procurement, and various other chapters that are important in the designing for prefabrication space. Now, it's fair to say that obviously this document has been developed around timber systems, but it's fair to say that the methodology, the majority of the chapters you've got in front of you are seamlessly relevant for other materials, other systems. Timber is obviously one of them, but the whole process and approach when designing for prefabrication is really no different whether you're working with steel or concrete precast, for example. So the majority of what you've got in front of you is seamlessly relevant across materials and across systems. The starting point for these guides that we wanted was, unfortunately, most of the time prefabrication and also timber often is an afterthought rather than the starting point for a project. Quite often that offsite even here that we get projects across the desk that are finalized architecturally, structural design, fully detailed, finalized, and then someone has the idea, let's prefabricate this building. And then it's obviously too late. So what we wanted to achieve with this guide that you've got in front of you is start from the very beginning. And the very beginning for every project, for you as the architect or for you as the engineer, is you will ask yourself the question, well, what is the most efficient way to realize a building project? There will be some constraints around that project based on the client brief. You may have to deal with tight timelines or poor ground conditions, climatic challenges, or urban context constrained in space. But our intention with this guide is that by educating the readership about timber systems and offering some genuine tips and pointers on how to design for prefabrication, you will be, going forward, you will be better equipped to pick and choose these systems and pick a system and match it to the requirements of your project. So that's the intention. When we talk about prefabrication, obviously that can mean lots of different things. Prefabrication can range from individual components to panels that are open or closed, to systems of panels, combinations of panels and pods, all the way through to completed buildings. So for timber systems, I want to look at some of these timber systems in a bit more detail. So one very important category here is open or closed timber frame panels. So these are timber frame panels. They are framed, can be framed according to NZ 3604 basically, but they're essentially made off-site in a factory. They can be closed on one face or they can be closed on both sides, and essentially then assembled quickly on site, as you see on the photo here. So the guide line contains a whole section on the various timber systems. I'm just trying to find the page for it. From page 5 onwards, where we talk about the different advantages and disadvantages of the various systems, typical applications. So that is intended to educate the readers about these systems that are being used. Another important category is solid timber panel systems, solid timber panel wall, floor, or roof panels. Most notably, obviously, cross-laminated timber that I suspect most of you will know, or other solid timber systems panels, product like PLT, parallel laminated timber, which has similar applications. Another category, just skimming through these categories now, panel and pod hybrids. So this is an example that Dovedale student residence down here in Christchurch, which combines pod construction for the bathrooms with closed prefabricated wall panels. So you can see in the photo on the left that the sole plates are ready, laid out on the slab and ready for these closed wall panels to be craned in to act in composition with the bathroom pods. Moving right along, this is the Cathedral Grammar School down here in Christchurch, a nice example of heavy post and beam and what that can look like. Again, it's got different applications, different advantages, disadvantages. Now let's talk about design for manufacture and assembly, which is really overarching approach to design when you're approaching or tackling a prefab project. So what is DFMA? DFMA is the design and manufacture of discrete sections of a building. So that could mean panels, that could mean pods, or that could be a combination of all of that. And the important thing here is that the design disciplines are well coordinated and free of clashes, so that you really coordinate well with between architect and engineer, between a collaborative approach that basically main contractor, prefabricator, key subtrades are involved in that design process at the earliest design stages to help inform what these discrete sections actually look like. How big is the panel size that you're designing here? Can it be transported to site, etc.? So it's really, the importance here is really collaborative. So basically your design needs to be informed from all the various angles, not just architectural, but also structural, from a contractor's point of view, buildability. From a prefabricator's point of view, of course, does it suit prefabrication? Can it be prefabricated efficiently? And also, once the DFMA design process is concluded, this needs to be coupled with lean manufacturing in the factory and lean construction on site. So that is important to say as well. Digital design and delivery tools need to be embedded into this approach. So it's really virtual reality modeling is really at the heart of this process. And I will talk in a bit about that that federated shared model that all these various design disciplines can use. Early collaboration. So you've decided you want to do prefab. You have got a project that you would like to target. So you want to pull together a team. Who do you involve? So the guide talks about who you should involve from the beginning and what to discuss during this early project collaboration. And this is really about establishing a team, a collaborative team, and building a collaborative team from the start, and talking about things like, well, what are prefab processes and systems available here? What's the degree of prefabrication you would like to target? More is not always better. It really needs to be tailored around the project. You need to talk about the importance of integrated design and BIM and how the project team intends to achieve that. How will you share information? You need to talk about the timeline. How is the timeline on a prefab project different compared to a traditional build? So this is where the prefabricator and the contractor need to inform that process as well. Building services. What's your strategy for building services? Do you plan to integrate everything in the factory off-site and just connect quickly on-site? Or do you want to opt for an approach where building services are dealt much more in a traditional way on-site, that yes, you have prefab panels, but these panels are open on one face and you can install services on-site. So these are early decisions you will have to make and early discussions you should have with the whole project team. The best way to illustrate this DFMA process and what it means for project delivery, integrated project delivery, is the McLeamy chart. So the chart I'm showing you here has become known as the McLeamy curve or the McLeamy chart. And experienced prefabricators love this chart and know this chart because it shows how the focus of work shifts compared to a traditional workflow to the front end of the design process. So if you're on the x-axis, we've got the various design phases right through the life cycle of a project, from the prelim design right through, or the early design, concept design, right through to construction. And looking at these phases, obviously your ability to impact cost and function will go down through the life cycle of that project, whereas the cost of any changes, design changes, will actually go up. And once you're into the prefab phase, the cost will go up exponentially if you want to make design changes. Yeah. So what does DFMA do and integrated project delivery do? What they do is they shift, they move effort, they move work to the front end of the design stages, so into the conceptual and design stages already. So the what, the who, and the how essentially get worked out much earlier as compared to a traditional workflow where a lot of that detail only gets solved and worked out once the contractor has been appointed, the project has been tendered out, the contractor has been appointed, and then he tries to figure out, well, how are we going to build this? So this is the key difference here between a DFMA approach and an integrated approach to project delivery, is really that we need to really front load the design process, and that includes the collaboration, obviously, with the contractor and the prefabricator. We need to talk about procurement here. This is a graph on delivery models from NZTA, the New Zealand Transport Organization, actually, but it summarizes very well the difference between a more traditional approach and and integrated approach to procurement. Basically, in a traditional approach, the goal really is to create some price competition by separating the design from the build phase into two separate contracts, separate them out, and create some price competition that way. Now, that gap that is introduced here between the design and the build becomes a major barrier for DFMA and what prefab is trying to achieve here. So the opportunities for innovation, the opportunities for efficiencies are severely limited in a traditional design approach, as opposed to integrated approach to design and procurement, where we require more time for pre-construction activities, but by the what, the who, and the how being worked out earlier by involving the main, the early contractor involvement, involving the contractors, involving the prefabricators, we actually we encourage innovation, we encourage innovation in design as well as delivery, and we are able to optimize the project early on. And that means tangible benefits for your clients through that DFMA process in terms of speed on site. It's more efficient and aligning the project with manufacturers and contractors' resources. So I want to return to your design process. You've got the collaborative team in place. You now ready to put a system, or you pick a system for your project. Start with a system. That's really important. Start with a system that matches what you're trying to achieve, and lock that system down with the team. Once you've picked the system, this has implications on the spans you can achieve, etc., etc. So that system really needs to be confirmed with the team. And just a couple of other ones I'd like to pick out. For example, standard details. Now, if you, for example, like timber frame construction, closed panels, standard details, your starting point there really needs to be the prefabricator. Keep in mind, these companies have done these jobs many times before. Experienced prefabricators will have a suite of standard details that are proven, that work well, and that you can take and adapt for your project. There's no need for you to invent standard details from scratch unless it's a very complex, unique type project. But wherever, if you have a system in mind and you want to deviate from the standard details the prefabricator supplies, you better get this cleared from the prefabricator, because it may compromise the efficiencies of the system in the factory. Yeah. And the bottom line really is you can save yourself a lot of work by talking with the prefabricator standard details. The experienced ones will have a suite of details, often actually well researched with test results to support them with regards to acoustics or fire. Yeah? The other things you need to talk about early, for example, I'm picking the services here. There's really three principal strategies if you want to get services into a closed timber frame panel. We can do this on site by leaving one face open, and we install these services very traditionally on site. Or we opt for a fully off-site approach where we fully close this panel, and we then have to work very closely with the prefabricator on how to actually achieve that. There's a lot more work in working out the detail, how this can be achieved. Or the third principal strategy here is a bit of a hybrid of both, where we fully close panels, but we work with draw cables or conduit to pull through services on site. Or we work with panels that can be opened up again on site to install critical plumbing features and whatnot. So what's really critical is documentation. I don't want to talk too much about that. What's really holding the DFMA process together is this federated model, that virtual reality modeling, where all the various design disciplines and stakeholders help to inform that model. And that includes obviously contractors and prefabricators. Now, at this point, all I really want to do is refer to the BIM, New Zealand BIM handbook. A lot of information there And if your project is reasonably complex, then you will have to be familiar with that. The key benefit to adopting BIM here, and the key benefit to highlight, is really that it facilitates the collaboration that we want. It really, literally and figuratively speaking, it becomes the common language between the designers involved here and everyone involved. I personally find it amazing how much agreement you can have around a table if you just talk about it, but it's not until you actually build that collaborative model and you look at where the clashes are and where the tricky connections are that you actually find out, well, we have to change this detail, or that you get to the tricky bits. So yeah, there's more information in the guide on this. Documentation wise, the average architectural and structural set should be fairly similar to a traditional set when designing for prefabrication. Of course, there are documents that are specific to a prefabricated approach, specifications concerning prefabrication, transport, storage, and assembly, or method statements, build manuals, of course. Factory shop drawings, QA documentation, that's typically up to the prefabricator to cover that and provide that, but designers sometimes get involved in that as well. So basically, design freeze, what it means is that at a fixed point in time, we lock the design in. So all the designers and the prefabricators and contractors, everyone can move, the design can move to the next phase with confidence. So on a simple project, that may be the point between all detailed design is finalized and you're applying for consent, or the consent is granted. And on a more complex project, that may be multiple freeze points. First you lock in grid lines, then you lock in a floor plan, then you lock in your opening sizes and your opening locations. So depending on their complexity, on a simple project, that design freeze is very likely to be only one point, which is after all detailed design has been locked down. Compliance, just very briefly, because it is something that naturally belongs into this guide. If you're designing with prefabrication and prefab systems in mind, it's important to know how to navigate the consenting process there. And what I'd like to point out there is the importance is to keep in mind that it's really a two-step process. Step one is getting consent, applying for consent and getting consent, and the step two is when the code of compliance certificate gets issued. At the end of it, for council basically has verified that what has been built matches the consented plans and specifications. And the reason why I highlight this two-step process here is it's at the time of your application for consent that you can make a case to the building consent authority that you're using an alternative process here, using a prefabricated process, and you can make a case on that the evidence of what's being built here can be gathered in a different way rather than just site inspections. In the absence of that, council will prescribe their standard set of site inspections and will send inspectors to site. But it's at that time of applying for consent that you've got an opportunity, you and the prefabricator have an opportunity to come up with a strategy, and by means of a design supplement, for example, to say, this is a prefabricated system, this is the QA system that the prefabricator has in place, and based on that evidence, based on that information, the council may reduce the number of inspections they require for this particular job. So rather than sending inspectors to site to look at panels, they may actually accept and can accept QA information that's coming from the factory, from the prefabricator. Essentially, what this guide is trying to do is it's trying to educate on the various timber systems, their strengths and their weaknesses, where they come in and how to utilize them. And once we sharpen the understanding of designers out there for the various systems on offer, designers will be better equipped to pick solutions that suit their projects, and you will find that you will be able to leverage that and to come up with better solutions and more efficient solutions. And it's easy for me to say that, but I'd like to just give you a couple of examples. They're random examples from overseas, but I think they illustrate well what I mean. So this is the Richmond Oval in British Columbia. This is a Olympic stadium, and what's remarkable here is, in my opinion, is these prefabricated roof panels that are hooked in between these arches. And if you look at them, they actually, all they are is they are 2x8 standard framing timber that is forming these arches with a steel tension cable down the bottom. And it's a prefabricated system, but to me, I can see that engineer, architect, and the fabricator and the contractor had to work hand in glove here to come up with this solution. This would not have been the architect in isolation or the engineer in isolation. They really had to be around the table and collaboratively come up with that. And very likely they've gone through iterations of doing that. Another example is a forest pavilion here in Germany. This is a plywood or cross-laminated type product. It's a panel product. It's 50 millimeters thick. It's 50 mil beech plywood, which essentially parametrically has been modeled into this unique organic shape. And again, I find it impossible to think that this was just the architect or just the engineer or just the fabricator coming up with how do we actually do this. You really have to work very closely together, collaboratively, sharing information, informing each other's designs to then come up with it. And the end result is stunning. The space that they've created here and very efficient use of material with 50 mil spanning quite a large span. And the last one I'd like to show you is a mosque that's made out of glue laminated timber that's just been completed in the UK. Freeform, organic, freeform shapes again. And again, this is relying on that DFMA approach. You would not be able to just architecturally finish this off and then tender it out and ask prefabricators, well, how are you going to make this? You really have to have your contractors involved from day one to be able to pull this off. Now, these are, I admit, fairly extreme projects, but to relate it back to something closer to home and something a bit more simple, final slide from me, or final project here, is this is a school that Concision have prefabricated a few years back here down in Canterbury, prefabricated and assembled from 200 odd wall and roof panels, prefabricated and closed in the factory. And apparently the speed of the roof assembly was 5 to 6 times the speed of a traditional build. But the reason why I point this out is here, it turns out the length of the roof panels in this assembly hall, in the sports hall, they are optimized to 12 meters length. And that turns out is the length of panel that the prefab factory can efficiently make. So in this case, because of early contractor involvement, the design was involved early to design something architecturally that could be made more efficiently than if this hall would be 12.2 meters, for example. So you tell me, constraint or an opportunity? I think it's an opportunity, and by better understanding the systems on offer, you will learn how to leverage prefabrication and come up with better design solutions. I hope you download the guide, you read it, and that you use it when you have your next timber or prefab project.